Section 9.4 Part B. So instead of answering all those types of questions on graphing a parabola or quadratic function, you could also just be asked for you to graph given the vertex and two convenient points. So I did number 5 for you, so try number 5 on your own, but let's do number 6. So we need to find the vertex, and then we're just going to use two convenient points. Now I like 5, but you really only needed 3 with the way the directions are written. So how are we going to find the vertex? Well, again, we're in this form, so we know to find the vertex we're going to use a formula opposite of b over 2a, and then plug that number back in to find the y part of the vertex. So b is 4, so it's going to be negative 4 all over 2 times a, and a is negative 1. So we get negative 4 over negative 2, which is positive 2. Now what do we do with that positive 2? We're going to plug it back in. So if we plug it back into the equation, we're going to have y equaling negative on the outside, 2 squared, plus 4 times 2 minus 2. So 2 squared is 4, but the negative makes it a negative 4. And 4 times 2 is 8, and then we still have minus 2. So negative 4 plus 8 is 4, and 4 minus 2 is 2. So my vertex is going to be 2, 2. So we have positive 2 for my vertex. Now draw your line of symmetry so you know that you are going to be symmetric over that line of symmetry. Now, one thing that I think is pretty nice to find is always the y-intercept. And we only said find another convenient point, and then when we flip it, we'll have our third point. So how do we find the y-intercept? We let x be 0. So we're going to have y equaling 4 times 0 minus 2. Well, that gives me a 0, that gives me a 0, so my y-intercept would be 0, negative 2. So 0, negative 2. I'm 2 units on this side, go 2 units on that side. Since it only asked for a vertex and 2 convenient points, those would be my convenient points, so I could be done at that point. So you'll do the same thing over here. What I did was I found the vertex and then I found the y-intercept. So if you want to find your y-intercept, it would be 0, 3. So try number 5 on your own. Make sure you can get that same vertex and a convenient point. Again, I like the y-intercept when it stays on my 10 by 10 grid. So now we get into wonderful word problems. These are going to take you a little bit of time, so please make sure that you're pausing the video, understanding what's going on, and then restarting the video when you're ready. So, a ball is kicked with an initial velocity of 36 feet per second. I want you to understand that 36 is already in the formula, so it's just telling you that it's being kicked at an initial velocity of 36 feet per second, but that's already put into the equation. The equation h equaling negative 16t squared plus 36t describes the height h of the ball in feet t seconds after being kicked. Let's think about this for a second before we look at what the question's asking. So here is since my coordinate plane. Okay, I'm not going to continue drawing it that way because I know I'm only going in this area. So let's think about this. Here's my t and here's my h. This is normally where my x is. This is normally where my y is. So I can see that my horizontal is going to be the t-axis and my vertical is going to be the h-axis. Make sense? So your height, h, and your t is in seconds. Okay, so this is in seconds and this is in feet. Okay. Now, looking at this equation, you should know if the ball is kicked from the ground or off the ground. Well, because there's no plus a constant, you know it's going to be kicked from the ground and it's going to go up and come back down. How do I know that? Because it was a negative a. Negative a means the parabola opens downward. And again, since there is no plus a number, you know you're going to be on the ground when you kick it. So let's look at part A. Part A says, after how many seconds does the ball reach its maximum height? We want to know the maximum height. Well, ding, 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 that's the vertex. right? But what part of the vertex? That's the y part of the vertex. The x part of the vertex tells you the number of seconds it takes to get to that maximum height. So we need to find the vertex. So how do we find the vertex? We do opposite of b over 2a, and then we plug the number back in. Now label this. This is your t, and this is your h, your x and your y. So label it as t and h. So what is my b? My b is 36. So negative 36 all over 2 times a, and a is negative 16. So negative 36 over 2 times negative 16 is actually 1.125. So right now, my x part, which is my t, is 1.125. Now that's t. Make sure you label that again. That's your time. They don't want to know the time. They want to know, well, do they? After how many seconds does the ball reach its maximum height? Yep, they do want the time. After how many seconds? So my time is 1.125. Now let's go ahead and find the y part of the vertex. How do you find the y part of the vertex? You're going to plug in the t back in to find your h. So h is going to equal negative 16 times 1.125 quantity squared plus 36 times 1.125. So you're going to have to plug in these decimals, okay? And when you do so, you're actually going to get 20.25, and that's your h. So let's make sure we answer the question. After how many seconds? Don't give me this h and k or this t and h, whatever your variable is representing. You have to answer the question. So after how many seconds is a 1.125? So for part A, you would say 1.125 seconds. Okay? It's just the first part of the vertex. Now what about B? B says, what is the maximum height? Well, this is not the maximum height. Not till we get to this point are we at the maximum height. And the maximum height would be the h part of the vertex. So no work needs to be done because we already had plugged that back in. So 20.25 feet. Now look at part C. Part C says, how long is the ball in the air? Well, it was on the ground and it took 1.125 seconds to get to this point. And those are going to be symmetric. So to get down here, it's going to be another 1.125. So it took 1.125 to get to the highest point. It's going to take another 1.125 to get back on the ground. So that's going to be, the ball is in the air for 2.25 seconds. So on part C, the ball was in the air for 2.25 seconds. Because they were symmetric, you can just double that time. Number 2, the function c of n equaling n squared minus 100n plus 5,000 describes a company's cost c of producing n units of its product. Find the number of units the company should produce to minimize cost. Alright, so let's think about this again. We're minimizing the cost. N is going to be on the x-axis and your cost is going to be on the y-axis. So this is your cost, this is the number of units. Now we know the graph is going to open which way? Well, it's going to open upward because n squared has a coefficient of 1. We know it's going to be on the y-axis and then come down somewhere along the way. And why? Because we know that y value, which is your y-intercept, was 5,000. So we know right at this point we're at 5,000 for the cost. Then the cost goes down, and then after so much, the cost starts going back up. So anytime you see the words minimize or maximize, you're pretty much going to be needing to find a part of the vertex. You just have to figure out which part that is. So when we look at the vertex, we're going to do negative b over 2a, and then we're going to plug that number back in to find the y part. But label which one is which. The first part is normally the x, so that's going to be my n, and the y part is the c. So with what the question is asking, do we want to know n, which is the number of units, or do we want to know the minimum cost? It says find the number of units. So the only piece we need is a negative b over 2a. So opposite of b, so opposite of 100, so negative 100 would be a positive 100, all over 2 times a, and a is 1. So 100 divided by 2 is 50. So that's all they're asking for, is what is the number of units they need to produce to minimize cost, and it would be 50. If they wanted to know the minimizing cost, we would have to plug the 50 back in to the equation, and that would give you your cost. All right, last one. A farmer has enough materials to build a fence with a total length of 400 feet. He wants to enclose the space to be rectangular and wants to maximize, again, we want to maximize the area that he encloses. Find the length and the width so that the area is maximized. So let's think about this for a second. He wants to enclose the space as a rectangle. So we have 2 L's and we have 2 W's, right? Now, we also want to maximize the area, and the area is length times width. So when you're talking about fencing, fencing is perimeter, and perimeter is 2L plus 2W. Why? Because you're just adding up all your sides when you go around the perimeter. And we know that with the total length, a farmer has enough materials to build a fence, the total length of 400 feet. So your perimeter is 400, equaling 2L plus 2W. Okay, be careful with that length is not really the L, it's the total length. So total length is going around the whole object, is 400. Okay, so what do we need to do? We need to combine these formulas. Well, how do we do that? Well, we're going to take our variable L and substitute in. So remember how we worked on getting a variable by itself? We need to subtract over the 2W and then divide everything by 2. So let me come over here for a second. I'm going to flip the 400 over to the other side. That's fine to do. We're going to subtract the 2W. So 2L equals 400 minus 2W. And then we're going to divide everything by 2. So we get L equaling 200 minus W. Now that we know that what L is in terms of W, you're going to plug it into your area. So your area formula is length, which is 200 minus W times the width W. When we finally do this, we end up with the quadratic equation. We get 200W minus W squared. Now we don't really like it to be in this order. We like descending order, so we're going to put the negative W squared plus 200W. Now that should look almost identical to this problem up here that we were doing when it didn't have that C value. So it's about the same thing, but we had to get to it. So for 1 and 2, they gave you an equation, which was nice, but on 3, you have to make your own equation. So we started off by finding out the perimeter was 400, solving for one of the variables in terms of the other, plugging it into your A because we're trying to maximize the area. Now, it says find the length and the width so that the area is maximized. So again, we are going to find our vertex. And how do we find the vertex? We do opposite of B over 2A and then plug the number back in. Now, what is going to give us each of these pieces? If you look at this equation, the W is where the Y is. So we really don't want the A because it just said find the length and the width. But we do want the first piece because that's going to give me my W. So opposite of B, so negative 200, all over 2 times A, which is negative 1. This is just the first part of the vertex. So negative 200 divided by negative 2 is 100. So that tells me that the width is 100 feet. Now, if we plug the 100 back in, that would give us A, but they didn't ask for A. They just wanted to know the length and the width. So now how do we find the length? Well, we know that the length was 200 minus W. So the length is going to be 200 minus 100. So the length is also 100 feet. So we have width of 100 feet and length of 100 feet. Much more difficult problem because they don't give you an equation to start with. So make sure you understand how I started off with the perimeter formula, plugged it into the area formula, and then ended up solving. Much nicer when they give you the equations to start with. Label your x and your y according to which variable should be here. Normally it's the x, and then this one would be the y, so you can label your axes accordingly.